Hi guys, welcome to the next lesson on writing Ionic formulae. So last lesson, in Unit 1, Area Study 1C.1, we talked about how ionic compounds bond with one another, but today we're going to be talking more in detail about how the formulae, so how the molecules bond together in their specific ratios, and how to determine this. So the rules for writing ionic formulae are as follows. First of all, you need to locate the symbols for your particular element on the periodic table. Then you identify the charges on that positively charged ion or the negatively charged ion. So using the groups of the periodic table, you can work out the charge. You can determine this charge, and that will help you work out the number of valence electrons it has. Then from there, you write the symbol for the positively charged ion first. You're always putting the positively charged ion, which will be the metal, first. And then you'd write the negatively charged ion, again using the groups on the periodic table to determine its charge, and then you'd write the two charges ions together, and you'd balance these charges. So, for example, the symbol for the positively charged ion, which is magnesium, and if you look at the periodic table, it would have a 2+ charge because it has lost 2 electrons. If you look at then the negatively charged or anion, you'd see it's a 1 negative charge. I'll just write that again to make it a bit clearer. 2+ for magnesium, 1- for chlorine. Given that we cannot have 1 electron gained by chlorine and 2 lost by magnesium, electrons cannot be left random or left running around. So we have 2 electrons lost. There's 1 and there's a second. We cannot have only 1 gained by chlorine. So we need a second chlorine there to gain that second electron, which is why we would then put a subscript, so below the element, of that particular amount of chlorine. So we'd have 1 magnesium for every 2 chlorine atoms because we have 2 chlorine atoms required to gain the 2 electrons that magnesium has lost when it became 2+. If you look at a worked example of this, determine the chemical formula of the ionic compound between zinc and nitride. So we know that zinc has a 2+ charge based on its location on the periodic table or its valence electrons in that shell, like 2+, and nitride or N3- means it wants to gain 3 electrons. So what we're going to do is, the easiest way to do this is to calculate the lowest common denominator of that particular compound. So we know that if zinc loses 2 electrons and nitride gains 3, the lowest common denominator of both would be 6. So if we get the amount of that particular atom or element as being 6 electrons lost or 6 gained, that would be balanced. Because if we just have 2 electrons lost from zinc, then nitride's still going to want to gain 1 more electron. So we can't then have another zinc lose another 2 because then we're going to have another electron left over. So we find a common denominator between the two. Common denominator is 6. So we would have how many electrons or how many lots of zinc are required to lose 6 electrons. So there's 3 lots of zinc is required to lose 6 electrons. And how many lots of nitride are required to gain 6 electrons? Well, we need 2 of them. So the compound would then be metal first, always metal first, zinc, 3 lots of them, Zn3 in subscript, and N nitride, 2 in subscript also. So here are the charges for all of the atoms, or the ions rather, for the cations, and here are the charges for the common anions, and you'll be given these. These apply to other slides in this presentation as well, so you need to refer to these in your presentation. They're located in your Chemistry 1 textbook. The writing ionic formulae for polyatomic ions. So with ions with more than one charge. So if there's more than one polyatomic ion, you need to have a formula which balances the charge and is placed in brackets. So a polyatomic ion, for example, is anything like nitride, NO3- or hydroxide, OH-. There's more than one element there. Sulfate, there's more than one element. So To balance the charge for these particular ions, you need to put brackets around them. So for example, magnesium, let's do an example. Magnesium has a 2+ charge. We know nitrate has NO3, has a -1 charge. That's also listed on the table previously. So NO3 would have a -1 charge. Nitride ion there, that's a -1 charge. Given that magnesium has a 2+ charge, you need to have 2 nitrates. Sorry, nitrates. You need 2 nitrates to gain those 2 electrons. Now, we can't write NO3 times 2 because that becomes 6. So, how we have the nitrate and how we have 2 lots of them is we simply put a bracket around it and we put a subscript 2, which means we have 2 of the whole compound, which would accept the 2 electrons from magnesium. Similarly, if you have iron and you have sulfate. So sulfate has a total of -2 charge. Iron has a +3 charge. In this case, it's iron 3 sulfate. So what we need to do is we need to work out, well, what's the lowest common denominator that's going to accept 6 electrons if this one gains 2 at a time. So the lowest common denominator is going to be 12. So this one here, we're going to need 3 lots of sulfate ions, each with a 2 negative charge, and they'll gain the 6 electrons. They'll gain the 6 electrons. So we have 2 lots of iron, that's Fe2, and we'd have to have 3 lots of sulfate. So SO4 is sulfate, and that's a 2- charge, which would only accept 2 of those electrons from iron there. So we need 3 lots of them to accept all 6 of the iron electrons. If we have 3 lots of them, we'll put a 3 there, which means there's 3 times the whole compound. So now that compound has the same number of electrons. The summary of today's lesson is ionic formulae must have an equal number of positive and negatively charged atoms between their cations and anions, and writing ionic formulae consists of putting the positive charged ions first, then with the non-metal second. Practicing these polyatomic ions is important, as you'll be given many of these in your assessments. So just going through and working out, putting the cation first, then the anion, and working out the charges balance. If they're polyatomic, you need to put brackets around them and balance the corresponding charges. The questions to complete for today are questions 1 to 4 of chapter review 4.4, page 101, and then for more polyatomic ion questions, also 1 to 3, page 4.5. Sorry, review 4.5, page 104. Thanks for watching.